On some new almost different sets from cyclotomic classes of order 12. Almost different sets have extensive applications in coding theory and cryptography. In this study, we introduce new constructions of almost different sets derived from cyclotomic classes of order 12 in the finite field GF of Q, where Q is a prime satisfying the form Q equals 12 times n plus 1 for positive integers and greater than or equal to 1 and Q less than 1000. We show that a single cyclotomic class of order 12, with and without 0, can form an almost different set. Additionally, we successfully construct almost different sets using unions of cyclotomic classes of order 12, both for even and odd values of n. This study utilized an exhaustive computer search employing Python to investigate this construction. The method involved computing unions of two cyclotomic classes, up to 11 classes, and assessing the presence of almost different sets. Finally, we classify the resulting almost different sets with the same parameters up to equivalence and complementation. Based on the findings, we have constructed a Q minus 1 over 2, Q minus 5 over 4, Q minus 1 over 2, almost different set in GF of Q from the union of 6 cyclotomic classes of order 12, where Q is congruent to 1 modulo 4. This set is equivalent to Paley, partial difference set, and can generate sequences of period Q congruent to 1 modulo 4, where K equals Q minus 1 over 2. Similarly, the same union of 6 cyclotomic classes together with 0 forms an almost different set with parameters Q plus 1 over 2, Q minus 1 over 4, Q minus 1 over 2, where Q is congruent to 1 modulo 4. In addition, we also have found 3 inequivalent Q minus 3 over 2, Q minus 9 over 4, Q minus 5 over 2, almost different sets in GF of Q from unions of 5 cyclotomic classes of order 12, where Q equals 13. The obtained 13, 5, 1, 4 almost different sets can generate sequences of period Q congruent to 1 modulo 4 with optimal autocorrelation values -1 and 3, where K equals 5. Furthermore, there exist 2 new inequivalent 13, 6, 2, 6 almost different sets which are not partial different sets, 2 new inequivalent 37, 6, 0, 6 almost different sets, 2 new inequivalent 37, 10, 2, 18 almost different sets, 2 new inequivalent 37, 12, 3, 12 almost different sets, 2 new inequivalent 37, 13, 4, 24 almost different sets, 3 new 37, 16, 6, 12 almost different sets, and 2 new inequivalent 61, 30, 14, 30 almost different sets which are not partial different sets, all generated from unions of suitable cyclotomic classes of order 12. Other new almost different sets are also constructed for Q equals 109, 229, and 877. In conclusion, this study enriches the existing literature by introducing an innovative construction of almost different sets via cyclotomy of order 12. The results not only broaden our theoretical understanding, but also open new avenues for future research and development in this area of mathematics.